Welcome back to Engineering Support by James, video number 13. In this section, we are going to learn how to calculate the center of the any section. And this particular video is for this I shape. So, as you know, in introduction, that center of gravity and centroid is what? The center of gravity G is a point that locates the resultant weight of a system of particle, and the centroid is the point which defines the geometric center. In this particular video, we are going to learn how to calculate the center of wide flange beam or the standard I beam. Okay, so let's start the problem. So I'm considering this I section having this three segments. A is 180 by 50, another one B is 80 by 50, and C is 180 by 50. Means this overall dimension will be the 180 plus by 180. So as you can see here, this particular problem, this section is symmetrical about both the axes. So basically the centroid in vertical as well as horizontal direction will be 180 divided by 2. So answer for x bar and y bar is 90, means the center is located here. Okay, but we will solve this by our regular method, means a regular textbook method which you are going to use in your exam. So we will consider this x bar here and y bar here. Vertical we will consider y, and horizontal we will consider as x. Okay, so let's start. What is center of composite area, and that is x bar. X bar means summation of area moment. Area multiplied by the distance means amount of this area divided by the total of area, which will give you in x direction, as well as in y direction it will be y bar. Okay, so let's start the problem. So this is our problem. Y is vertical, next is horizontal. So first we will calculate the x bar, and I'll consider the distance from y axis. Okay, so first of all we will start with A means area L by B. So I'm considering all the horizontal distances first and then vertical. So 180 multiplied by 50, it will give you the total area 90,000, and then we will calculate the CG from Y. It will be 180 divided by 2, so it will be 90. So area multiplied by CG is equal to 814 times 0 mm cube, mm square, sorry. Next is B. B is 50 horizontal, this 50 multiplied by this 80, which will be equal to 4000. Then we will calculate the CG from Y, which will be equal to 65 plus 50 divided by 2, which will be equal to 90 only. And the area multiplied by CG equal to 36 and 4 times 0. So area multiplied by CG is mm cube in this case. So next is C. C is exactly the same as A in this particular case, so I'm not going to explain it. You can see here is 180 multiplied by 50, which will be equal to 90,000, and CG will be 180 divided by 2, so it will be exactly 81 4 times 0. So we will calculate the total area here, that is 22,000, and the area multiplied by CG equal to 198 4 times 0. So x bar is equal to sigma x, means this area multiplied by CG is moment area divided by total area. Then this value is 1984 times 0 divided by the total area, that is 22,000, and it will give you the answer as 90 mm. So this is your x bar, means it is locating somewhere here from y axis. So next is we will calculate the CG from this x. So we will consider from bottom, the here C is equal to area is equal to 180 multiplied by 50. The area will be obviously 9,000, and is the CG from x is equal to 50 divided by 2, which will be equal to 25. So area multiplied by CG equal to 225 3 times 0. Next is B. B is again 50 multiplied by this 80, you can see here. So area will remain exactly same, 4000, but the CG from x will change, that is 50 plus 80 divided by 2, which will be equal to 90. So total So area multiplied by CG equal to 36, 4 times 0. So next is E. I'm considering this segment last. So it is exactly the same as 180 multiplied by 50. Next is 9000 will be the area, 180 into 50. So CG equal to 50 plus 80 plus 50 divided by 2 means CG from the reference point. Okay, so it will give you the direct answer as 155 multiplied by 9000, which will equal to 1395000. So total area will be equal to 22,000, and then the summation of area multiplied by CG equal to 1984 times 0. So y bar is equal to summation of moments about x-axis divided by the total area, which will be equal to 1984 times 0. You can see here it is exactly same, and it is also exactly same. So answer will be 90. So as I told you that this is a symmetrical section, you can check it. So 180 divided by 2, and in this case also it is 180 divided by 2. So answer is 90. So thank you. Next time we will start with the moment of inertia with respect to the centroidal axis. Thank you.